Okay, first thing, we try to get through the quiz. Okay, so now I just given you the right answer. Okay, so the first one, which one you think okay? Let me know. Number one,
Sorry, Professor, are we supposed to upload the quiz?
no,
No?
no, that for your
Okay.
study. Who get the answer number one?
I thought I was 5.1 volts.
Just tell me A or B or C.
A. No, B. I'm sorry. B.
That will be B. Okay, again, I'm telling you, when you get the zener, okay, before you want to do it, you're supposed to whip down the zener, what we are. If we in a 20 volt, then we out will be 20. 20 is higher than zener voltage. So zener will be break down. Okay? When they break down, they will be 5.1. Okay. Number two, current. If you get a 5.1 this side, okay, and 20 this side, then you can calculate the current. Go through R1, okay? So should be 20 minus 5.1 divide to 1.5 K. Okay? Who get the answer?
A.
9.9 milliamp. Okay? Number three, V in 3 volt, then V out. Who get the answer?
Hey, Mr. Fams, just so you'll know, your screen is really small. You can barely see it.
Oh, can you see it?
It's really, 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 really small. You need to make the screen bigger.
Let's see. Better?
A little bit more. Yeah, that's better.
So, when you get a 3 volt in the input, that will be telling you without a diode, then you get a 3 volt. And this is a round, so the signal will be open. That's why the answer will be 3. Okay, number 4. Okay, and then they calculate the current through resistor. Who get the answer? And the number 6, current through the load RL. Should be 8.33 milliamp. This is just a very, very basic. We not go into too much detail. Minimum, when you see that kind of circuitry, you're able to do your calculation. Okay? Number 7, they want V peak at the secondary. So number 8, they want the phone out DC. What the VLDC here? That will be minus 0.7. Number 9, They want to know Vout. Speak. The thing is, when I try to help you on the MSIM7, then I can prove it for you. How come to get 54.5? Okay, number 10. Okay, had a sawtooth waveform. 11. Well, 13. Number D. That one. Okay, so basically, that's just a very, very basic question. Okay, you need to know. Any question about the quiz? You don't have to upload. I just want to make sure, basic things you have to know about this part of the semiconductor. Okay, now I want to talk to you about your lab. Okay, you understand you will be using the digital oscilloscope and the generator. I just get a question to you. Okay, before you try to working with your leadboard circuit, okay, then using this equipment have to be no problem. Otherwise, you get too many problems. Okay. Okay, 14 generator here. Okay, if you want signal, that means you will be using sideways. Okay, and whatever frequency you want. If you set 1 kilo hertz, that means you can go from 0 to 1 kilohertz. 10K, that means you can go up to 10 kilohertz. Okay. If you get a question, have to stop me, okay? Let me know. If you want amplitude, this is the amplitude, okay? And now, only you connect the output, okay, to your circuitry and to your oscilloscope. Okay, now, what else? If you apply 2 volts peak to peak or higher, no problem. However, if they say, I want output 3 millivolt peak to peak, what do you have to do? In order to get 3 millivolt, who knows? Let me know. I want to get a sideways frequency 1 kilohertz, and the amplitude will be 300 millivolt. What else do you have to do? Hello, Mr. Smith. Do you know how?
I'm sorry, Mr. Pham, I was away from the computer. What are you talking about?
What I'm talking about, I want the output of generator, 300 millivolt, peak to peak. at the frequency 1K sine wave. We already did.
You can hook the oscilloscope up to the output of the computer, to the output of the generator, and then move the dial till you get to 1K.
What do you mean 110?
No, I said 1K. I thought you said
No,
1K.
we already get a 1K.
So
We
what are you
already
trying to
get
get?
a sine wave. Only thing is, now they want 300 millivolt peak to peak. And I can tell you one thing,
So then you could use the amplitude.
that amplitude. But what I said, when you turn down amplitude to the minimum, they given you only 2 volt or higher. You cannot get 300 millivolt.
So then you have to use the offset of the sink.
Exactly. Now you can see on that they get an offset. Okay? In case they get 300 millivolt, 400, 500, amplitude cannot give a this small voltage. So you have to pull out offset, not here.
Hey, Mr. Pham, can I make a suggestion?
Yeah.
I think that one of the reasons people might be having a problem is you need to actually have the devices hooked up so that they can see what's going
No, no,
on.
no, no. Right now I just talking about the output of generator only.
Right. That's what I'm saying.
No, that if they follow that later on, they can get that.
Okay.
Otherwise, look confusing.
All right. I see what you're saying.
Okay. So what I say, if you get a voltage less than 1 volt, like 300 millivolt, 400, 500, only thing what you have to do, pull out, offset not, okay? That can give you up to 300 millivolt. So that's why I want the student understand what generator can do. Okay, any question, anything, just let me know. The thing is you have to speed up in the left wall. Try to get the DC done. You go to uh, semiconductor, okay? And you can go to transistor, DC, and amplifier. So basically, when you're looking into the generator, you can understand what you need to do.
Mr. Pham, so
Yeah,
can the offset be done on the Multisim 7?
multi-sim. Oh, no. On the multi-sim 7, different story.
So you can't do an offset.
No, no.
Okay, thank you.
Yeah, this is just a real generator using in the lab. Any question? Okay. Now, if not, let's see. Okay. Now talking about the scope. This is connect channel 1, connect channel 2. Now, I said yes. Before you using the oscilloscope, okay, you can connect channel 1, okay, and channel 2 into the generator, okay. What we want, normally, you have to set first window here, channel 1, second for channel 1. And the first, you want to measure the peak-to-peak voltage. The second, you want to measure the frequency or period or whatever you want. Okay? And the next window should be channel 2, measure the peak-to-peak, and channel 2 to measure the frequency. Okay? So, when you display, you can get signal. Okay? And now, I'm telling you, how can we do? Okay? On the any level computer, you get what we call the file OSC. Okay, head. You double click on that. Okay. On this tab in here. Okay. If you want to set each window to design channel, you press number 1. Okay, first thing, they're telling you, press auto set and measure. Okay. Then you press the top. This is the top button to select the source. Okay. From next window, you select channel 1, channel 1, channel 2, channel 2. Okay. That's what you get. Connect that one. Okay, number 2. Set scope probe to match your probe. Okay. I enter number 2. They're telling you, press channel 1, okay, menu, or channel 2, menu, okay. Press the button to change on the probe window. Okay, basically, how different between by 1 or by 10 probe. You understand it from the top to the bottom here. You get 1, 2, 3, 4, 5, 6, 7, 8 division. Okay? If you set 5 volt per division, maximum you can measure up to 8 times 540 volt. Any voltage higher than you cannot display. Okay? So, the scope allows you to set to scope to 10 times. Okay? That means you get a signal is too big, like the output of your outlet, over 300 volt peak to peak, then you cannot measure. So that's why you have to set your scope probe and the oscilloscope at the same 10 times 10x. Okay? However, I can tell you, when you're working in this lab, don't try to set to 10x, we don't care. In the left volt, they're telling you how to set up, how many volt, set 10x. No, don't care. We don't care about that. The thing is, left volt, they did it long time ago. They're using an analog scope, and that is not really good at this time. At this time, most of the company using a digital scope. The thing is cheaper now. Okay? So we don't care. On the left one, they say set 10x. Okay, probe, and set how many volt per division. Everything, we don't care. We just care what they want the voltage. Then you can set it. Okay? I show you again. They're on the oscilloscope probe, they get 1x, 10x. Okay, press it back to 1x. If you want 10, that's okay. Put it 10. However, you also set your oscilloscope, okay, to 10x. In order to do it, you press channel 1 or channel 2, press the button to change on probe window. Okay? Another thing. Number 3, set coupling. AC/DC. What's the difference? If you set AC, what happens? And if you set DC, now, if you set DC, what happens? Oscilloscope will be displayed DC and AC. If you set it coupling AC only, so they will be displayed only AC. You don't want DC, okay? In order to do it, you type in number 3. They're telling you, press channel 1 or channel 2. Press the button to change and coupling window. Okay? That means everything they already telling you. Okay? Now, in order to set the measurement, okay, number 4, you want to measure. First thing they telling you, press auto set, then measure. Okay, you can see, understand how come they want you to press auto set and measure. Okay, auto set and measure, auto set, measure. The reason is, every time you're changing on your generator, on the scope, anything changing, you must be set auto set, then measure for the oscilloscope update to the information. Okay? So, first thing they're telling you, press auto set, then measure. Okay? Then you press the top button, select the type, press X window to select what type of the measurement. That means you want measure V peak to peak, you want measure period, or you want measure frequency, then you can change. Same thing for X window. Okay? And now, if you want to measure using the cursor to measure the time, okay, cursor to measure the voltage, we see what on number 5. Okay. In here they say, press the cursor right here on the time window. Okay. Select the time on the short window. Select channel 1 or channel 2. Using position to move cursor left or right. Read the data in delta window. Okay. I think the last of this one, you use cursor to measure voltage or measure the unground voltage at the 7 here. That takes you a little time. Set both channels at same voltage, press the match function, press channel 1 minus channel 2, press cursor button. Okay, in time window, select voltage. In short window, select match. Move the cursor to the measurement match voltage. Read data in the delta window. Okay, we get this program here on every computer. When you need it, you just click on that. They're telling you what to do. Okay, any question? So basically, the first time you want to do the lab using generator oscilloscope, first thing you connect generator to channel 1, okay, and the channel 2, and you set window 1, 2, 3, 4, okay, to what you want, okay, measure V peak to peak or measure frequency, and let they can display on the oscilloscope. That means your generator and the scope working okay. And now you start connect into your circuitry. That is the easy way. If you still get a problem, how to set up oscilloscope for channel 1, channel 2, channel 3, channel 4 to measure what you want, then you still get a problem. Okay? Now we go into transistor, DC. Okay, this is a symbol for the transistor and NPN. Transistor to get the base, collector, and emitter. For NPN, the current flow, IB, IC, and IE. So that's why you can see IE equal IC plus IB. Okay, I don't care about IC very close to IE. Okay, doesn't matter. Okay, and this is a symbol for PNP. Okay, so they can get the same current, IB, IC, IE. However, IC leaving. See that? IB leaving. IE coming in. So by looking into the symbol, arrow come out, arrow coming in, you know NPN or PNP. And the formula will be the same for both one. Okay? Now, this given you a little more physical. Okay? And this is NPN. So this is the N side. In the middle is the P side. Okay? And if you get a PNP, then that will be a P, that will be a P side. So basically, you apply the voltage, electron will be moving. That's why you get the current. Okay? And this will be telling you N side for transistor and the P side. You see only the different arrow will be one point out and one point in. And this arrow just a diode. Okay? Now, you can see this is a transistor. Okay? And NPN. NPN, it is the base, collector, emitter. So from the base to the emitter, you get a diode here. Base to the collector, you get another diode. And PNP will be opposite. Okay. Now, for the circuitry NPN, okay, they say determine beta NIE for transistor, where they given you IB and IC. Okay. So one thing you need to know, NPN, you can get this is the base. Okay. This is collector admitter. Okay. And this is diode, so you can get plus here, minus here, V, B, E. And diode we're using 0.7 volt. Same thing on the PNP. Only thing is the diode will be plus here, minus here, and the value 0.7 volt. Same thing. Okay. So in the both transistor, beta equal IC over IE. Okay. They given you IB. Okay. And IC. That one you can substitute. You can get a beta for both one. Okay. Now, for the NPN transistor here, okay, this is the base collector admitter. Okay, and from the base to the admitter, the diode will be 0.7 volt. So now, the base circuit is usually analyzed with the same approximation used for the diode. So this is just a formula, okay? They given you to do all of the calculation you need, okay? So the first one, I can tell you, they need to draw the loop voltage here, I. So when they go into VB, they go to negative, and that is positive. So that's why minus here, minus VBB. And they plot IB times RB voltage. And they hit to the base, plus minus 0.7. Okay? And everything equals 0. So from this formula, you can calculate the IB. Okay? And for the voltage VRC, that means the voltage VRC right here. Okay? VRC equal IC times RC. So If you get the IB, okay, and you get the beta, you can calculate the IC. And the voltage drop across RC will be IC times RC. And now they calculate the VC. VC means from collector to the route. Okay? Then VC equal VCC minus the voltage drop across RC. That's why you can get VC. And VCE, that means from C to E, okay, equal VC minus VE. VE connect to the route, okay? And you want to calculate the IE. IE equal 1 plus beta times IB. And IC equal beta times IB. And finally, if you want to calculate the IB, you already know IE. IB equal IE divide 1 plus a beta. Okay? That if you need any formula, you can using those formula for your calculation. Okay, now they want the atomic IB, IC, IE, everything here. For the circuit show, they get a beta 150. Okay. VBA equal 0.7. That means diode voltage. VBA. Okay. VBA. Answer will be 0.7. IB. Okay. If you want to get an IB, you need to draw the loop. The current I. We already showed you. And after you get that, you can get the answer here, 0.43 milliamp. Okay. After you get IB, okay, if you want IC, beta time IB. If you want IE, normally IE equal IB plus IC. However, never using this formula. The thing is IB is too small. So, what you can do, if you get IE, IB, then you can get IE 1 beta time IB. Okay, so IB 0, IE, IB 0.43, IE 43.01 milliamp. This is the answer for you. You have to spend the time to working on. Now they want VB. Okay. VB, that means from here to the ground. That means you get a diode here, you get 0.7. Okay? VB 0.7. VE, that means from here, okay, to the ground, they will be 0 volt. And VC, that means the difference between VCC and voltage drop across RC. So VC okay, VCC minus IC and VCE equal VC minus VE. Okay, so basically you have to get the time to go through it and do your calculation. Make sure you can get the answer we given to you. If you get any problem, and just let me know. Okay. Okay. Now, region of operation. Transistor, they can be cut off. Okay. Active and saturation. Now, in a cutoff, they using in the switching application. Active used for amplifier. Saturation used in switching application. Okay. And the last breakdown can destroy the transistor. So basically, either they can be cut off, or they be active, or they be in the saturation. Okay, and they're telling you cut off diode from B to emitter E off. Active diode from B to emitter E on, and diode from a B to collector will be off. Saturation, both diodes are on, and VCE equal 0 volt DC. Okay, so this is the condition. Okay, what happens if they cut off, or they active, or they saturated? If you want to transistor to be amplified, they must be active, or like the switching on and off. Then you have to using cut off or saturation. Okay, now this is the circuit. Example number 2. For the circuit show, what VCE when VE in equals 0. If this is 0 here, what VCE? Now, when you get the input at the base, 0 volt, that means no current flow. Okay, transistor will be off. Off means what? They will be open. That means no current flow IB, no current VE. Okay? And basically, no current, okay, go into here. They can go, but they cannot go anywhere. The thing is they open inside the transistor. Now, see solution. When V in equals 0, transistor is off, IB, IC, IE equals 0. Okay? Therefore, VC, that means the voltage here, okay, equal VCC in here, okay, equal VCC and equal 10 volts. So that will be telling you the voltage here will be 10 volts, okay? So if you measure from the collector to the ground, you get 10 volts. The thing is they cannot flowing down. No I current. I see. So no voltage drop across RC. So this side 10 volt and this side will be 10 volt. Okay. And let's see, since the transistor is saturated. Number B. What minimum value of IB required to saturate this transistor if beta equal to 100? C. Since the transistor is saturated, they're telling you VCE from C to E equals 0. Then IC saturate equals VCC divide RC. You get 10 milliamp. Therefore, you can calculate the IB. Okay, 50 microamp. Okay, calculate the maximum value of RB when V in equal 5 volt. Okay, when the transistor is on, voltage across RB, VRB equal V in minus VBE 4.3. Okay. Then RB maximum equal VRB divide IB minimum. Okay. 50 micro. So you get RB, okay, equal 86K. That's the value here. Okay. So if you get the time, okay, before we get a meeting next week, try to go over. Okay. Any question, anything, I try to solve that for you. Okay. Before we can go more. Okay. This is the last one for today. You can see this will be the graph of IC versus VCE. This is the VCE here. That's the VCE. Okay. And this will be IC. Okay. And inside here, that current for IB. Okay. IB equal 20 millivolt, 40 microvolt, 60 microvolt. Everyone on this line will telling you the value of IB. Okay, now see, if I get a point here, looking at the point here, what IB equal? Right here, 60 microamp. Okay, if you want IC, you go to the left, you can get around 8 milliamp. If you want VCE, you going down. You get 10 volt in VCE. Okay. So this is the NPN here. IC coming in, IB coming in, IE leaving. Okay. So up to this point, any question? The thing is you have to really understand the basic DC for transistor. They get NPN or PNP. They working exactly the same, only the difference is the current flow. Okay, IB, NPN, IB coming in, IC coming in, IE leaving. PNP opposite, IB leaving, IC leaving, and IE coming in. That's only the difference. Okay, so this what they call a set of curve, also called a family of the curve. Okay, for NPN. Okay, and later on, you can see, you can get a region here. Later on, they say this is a saturation region, and you can get a part in here, region in here. That means the cut-off region, and any point in here, that will be active. Okay, you can see active here, or saturation here, and this is the cut-off. Okay, so you get any question, anything? Okay, we will be continuing on next Thursday. Try to finish DC. Then we can go into amplifier. Okay, and also, if you're doing the lab and if you get a problem, let us know. Okay, you done for Ohm law. That means you already done for DC fundamental. Then you have to working on semiconductor. Okay. Okay, any question?
Hey, Mr. Pham, just one thing.
Go ahead.
I know you're doing Tech 1 stuff right now. When you get a chance, can you check D Review 1 for Tech 2?
The review 1 for that you.
Yeah, thank you.
I need to look over that.
Yeah, thank you.
Okay, but I cannot answer you right now.
Yeah, I understand.
Okay, so We'll see you guys, okay?
Is there possible to like do a few labs in one time? If not, if I can't like attend the offline classes for now.
Can you say again?
I'm saying, is it possible to do a few labs in one time? Like several labs in one time?
What do you mean 7 lab?
I mean,
You're talking
I
about
will
lab?
check, so that's okay. I will send you the email, okay?
Yeah,
After the
you're talking about lab 1, right?
lab work. Yeah.
Okay. You done on the DC, and now you're working a second board.
I
Semiconductor.
mean, I haven't attended any lab work, and I'm asking, can I do like few lab work in one time, in one visit to the class?
Okay, you can do. Try to get that cover anything in the semiconductor that's the next circuit board.
Oh, okay.
Okay.
Yeah.
Normally, I'll be in the class on Monday. Okay. I
Okay.
will try to help your guy out.
Thank you.
Okay. Get it done as much as you can. When you get everything done, you can take, half month for vacation, no big deal. You already done. When you're coming in, you need to sign in. That's required from CT. Okay? But the program we run a little different. We need the job done, nothing else. Not the hour. We don't care. You can stay in the program for a long, long time if you cannot get anything done. Okay? So,
Oh, thank you.
okay, good night, everyone.
Good night.
Good night.
Thank you. Bye.
Good night, Professor.
Good night. Bye-bye.
Bye bye.